This world is broken. The science is outdated, the math is incomplete, and the people are so blinded by greed that they cannot see the way forward.
Wait. You're not thinking of intervening, are you?
It has to be corrected. Knowledge is not a commodity. It has been and always will be their future. Standing in the shadows is no longer an option. We have to teach them to share freely without fear of retribution.
There is too much to teach for just one person.
I know. We will have to recruit more people who think the right way. The people who have been shunned by the mainstream. People who have the passion in their heart for the science.
How do we find all of these people then?
We create an open forum to discuss ideas and build ties. We let everyone have a voice, and we never let greed dictate our path.
What do we call it then? Oh, I got it. The Fringe Think Tank.
The Fringe Think Tank it is then. Now let's give them back their destiny and open it up to the world.
Hello everyone, my name is Nathan, otherwise known as Old Man Bill. The Penny Factor will be here with us shortly. Guys, we got an awesome show tonight. We're going to talk about some over unity. We're going to talk about Edwin Gray and his little car. For those of you who don't know what it is, this little Geo Metro right here, he got it running on electricity and it's self-charging. Pretty awesome. I got a whole video set up for everybody. Just want to say hi to everybody and then I'll start playing the video. What's going on, guys? Been rocking it out today. UFO video, egg. That was a big hoax, wasn't it? Just looked like a real egg. All right, guys. Right on. All right, let's go ahead and get into it. Ben's back. Right on, Ben. All right. Put this on here.
Beautiful automobile. You can drive it anywhere you want to. You don't pollute the air. All the other electric automobiles that I've actually seen has been nothing but this standard transmission. This is an automatic transmission car. There's not a whole lot of what you call junk, I would call, under cars. I've seen a lot of electric cars that had a lot of stuff in it. The only thing that this has a battery to run the radio, the blower. We've got two safety switches over here that can be mounted into an enclosed system, but we did this where you could see, where people can see this car with the technology. It's a safety switch system. This is a controller box, a Curtis control box. It cuts the amperage down. So with the amperage, here's what's real good about electric automobiles. All electric automobiles that has surge technology with this in it, they create heat. They've got to have a fan to blow this Curtis controller off because it gets hot. We don't want that to get hot. We want to stay that cold, because once it stays cold, you save on all the computer chips that's in this controller. So that means you can go farther, longer, and you won't have no problems. This electric automobile has got two gauges in front of the shifter on the automatic transmission. It's called the voltage and the amperage. That's what I was talking about earlier about amperage on automobiles. Let's see if we can't get the amperage to go down instead of going up. The voltage on this here should say somewhere around 120 volts. When we start out, there's no amperage at all. So the gauges is down below here, and we're getting ready to take and go drive the car, and you can see for yourself what it does. All you do is to take and put it in gear, and the motor sounds like a little sports car. Shifts, runs good, fantastic automobile, drives. If you'll see the amperage on the gauge, see it going down? Amperage goes way down. That's what I like about electric cars. If you floorboard the car, the most it will do would just be about maybe 100 amps. And that's what we want to do, is to keep the amperage down on an electric car. So it'll go anywhere really anybody wants to go. If you want to take a trip, you don't have to worry about it going to go plug it in the house, because it's called the surge technology. It's a beautiful automobile and I love it, and I've put a lot of hard work in this car, and we're going to make it. No oil, no gas to fool with. And the technology is here. It's going to be here. It's going to go. It's going to work beautiful for the whole world, for mankind. See you around. This is your future, people.
I want to talk to you today about Edwin Gray. He made a car that was... I want to talk to you today about Edwin Gray. He made a car that was rechargeable as he drove it. It's an over unity car, free energy car. Really interesting concept, but he did something that was so revolutionary that we weren't ready for it. Yet it goes back to the 1800s with Nikola Tesla is exactly what he was trying to do. He created a radiant energy that's not positive, but it's negative. Let's go ahead and take a look at his circuit real quick. This is the Edwin Gray circuit right here. This is part of it. So what you got over here is a bunch of flipping switches. So if I just said this was a ZVS, and I basically drew a primary, this is my secondary, and then it goes this way, right? You go, well, hold on. Why would you say that? What makes you assume that? Well, it's because of what he created right here. You see, right here he created radiant energy in the negative, not the positive. So how did he do that? He'd used a gray tube is what they called it. It's simply a rod. It's got another cylinder around it. And another cylinder around it. And they're encased by another cylinder. These right here are mesh, or it would have a pattern that was like this with little holes in it. You get the idea? Anyway, what is he trying to do here? Well, let's go back to Nikola Tesla for a minute. This is Tesla hairpin circuit. This is the key to understanding Edwin Gray. You see, this right here, you have a direct circuit. So this is your driver circuit. It goes into your primary winding. Secondary winding goes into a spark gap. Capacitors right here. This right here went to a medical device, which we won't be talking about today. But what was he doing here? You see, Tesla created a negative radiant energy right here. And here's what he did. He took this field here that's created here, and he forced this field here to flip. So as that field built out, it could not build the correct way. So if I told you this is the dielectric, and inside of that was his magnetic, well, he couldn't build it the same way going out. So what happened is it reversed. So now, if I do that, his dielectric went inside of his magnetic field. Now, that's pretty interesting, right? It's a reversal. It's a flip of the field. So if I drew it out like this, and then I told you it was right here, and this is your dielectric, this is your magnetic, right? What did he do? He took it and put this into here, so now it builds a different field. Well, there's another way to do this, and this is the most important part of finding this out. If I put a rod down the center, I now have the same thing. Let's go over this real quick. I'm switching the field now, like this. Now this is very important to Edwin Gray. This exact way of doing it is what he did. So if I said that's cold radiant energy right there, which means that there's not a lot of heat into it, right? The only heat comes from the RF itself. So, now that we understand that with Tesla, and Tesla already did it, and he said it was a massive power source bigger than the radiant energy that would come off of his Tesla coil, which it is, because I built it. Now let's understand that same concept right here. Simply have coil over coil right there, which is this cylinder. Now, there's your rod down the center, right there. There's 1 and 2 cylinders. Why is it there? Well, funny thing about this energy is it builds like a scalar field. You see, I have trouble with Steinmetz and what he says because it takes voltage and amperage in order to make a magnetic field. It would also take voltage and amperage to make a static field. Therefore, what radiant energy in the negative is cannot be those two items. It has to be something different. It's an inversion of the field. Now, if I understood it in that way, Edwin Gray makes all the sense in the world. Because, say this right here is your gas pedal, right? And I want to push on that gas pedal. I'm going to create heat in this device. You see, the funny thing is about radiant energy is when you put things too close to each other, it flips the field back. So if I told you this is how you built it, but then I go over here and I put it into this, right? Then this field becomes this field on the outside. But what does that mean if I wanted to flip it back again? I now simply flip it again. Edwin Gray was doing this. This energy was where he created his radiant energy field. It went right through this rod. But as he adds heat from a secondary battery, it then flips the field to hot. Once he flips the field to hot, now this starts to make sense. Spark gap for radiant energy, right? This comes back as radiant energy because this part is his generator. This part is his motor. Now, as I push the system through, this amount of energy will pull here and shoot one way through the spark gap. But then, as it runs and he takes his foot off the gas, the energy comes back and fills up the radiant field. You can't overcharge the radiant field. The capacitors here both pick up the extra energy. See, the capacitor doesn't care whether it's DC or radiant energy. To it, it's just a field of energy inside the capacitor. You see, this device works based on Tesla's radiant energy. If you don't understand it, take your Tesla coil, put a rod down the center directly in the middle, and pull the energy field. That energy field is way more powerful than the field on the outside. So let's go back real quick. Tesla's radiant energy. This is his hairpin circuit, guys. This is why I keep telling you it's the same energy. You see, you can create energy more than one way, as long as you get the right effects. Energy field here. What happens if I do this? If I simply wanted a bigger rod to go down there, that energy is no longer cold. It's now hot. I just flipped the field by changing the geometry. But that's exactly what Edwin Gray was doing. We look at it right here. All I have to do is create heat in here and change the energy. That's it. If I add a DC to this field, what am I doing? I'm creating a lot of heat. I'm adding massive amount of amps to it. Now as I add the amps to this field, guess what? My radiant energy now becomes hot. I now add to that amperage field. Now I'm getting an uptick in my amps going this way. It's not crossing back over because the amps are okay to go into the capacitor. It's going to go right through the motor. This is why his device works. It's a loop that's continuously running. This will run itself through this right here. Do this, it continuously runs itself. This is added power to flip the field. Your battery on this side, and this is why I call it a ZVS, is it's simply running two switches that go onto a coil, which switches onto another coil. If you understood Tesla's device, like I told you, if I took my Tesla coil and I ran the rod right down the center, then you would understand that I am simply taking that to right there. You go, well, that doesn't look like that, but that's exactly how it's built. You see, in order to get this, you have to understand field flip, and you have to understand which side of the field you're on. That's why it makes more sense when you look at Tesla and you go, this right here is an inversion of the field. I'm moving my dielectric inward. Now I'm going to move it back outward in order to get more magnetic field. You see, if it was creating static electricity, it wouldn't do that. If it was creating just magnetism, it wouldn't do that. Tesla discovered negative radiant energy. What does that basically mean? It is simply room temperature and below. That's it. It's not this massive cold streak. Negative energy, cold energy is simply room temperature and below. It can go down 5-10 degrees. That's it. It's making your circuits cooler as they run. You're reducing the amount of heat in your system. That's the goal here. When you look at his patent, find me a resistor. If it's in the ZVS part of it, like I pointed out, that's fine. If it's in a control board, that's fine. If it's in the main circuit where he's creating his energy, you know he's not in cold energy. You know he's not in the radiant energy. Because a resistor in that area produces heat. It's not what he wants. He wants it to be cooler. He wants to keep the cold. That motor runs continuously just like a regular motor would. That's why he's always pulling energy back. He adds the heat to it in order to move it. Now, you say, how's that even possible? Does electricity work that way? This is the understanding of scalar, okay? If I wanted to take a mountaintop, I have a frequency, I have a temperature. This is controlling the temperature in your system. I just have to know this about energy. The higher the frequency, the lower the temperature. The lower the frequency, the higher the temperature. Now this will convert into volts and amps. As the frequency is up, your voltage is higher. As the frequency is down, your amps are higher. Interesting how that works, isn't it? This is why that magnetic field that Steinmetz talks about can't be magnetic. It's scalar. It's building out in the exact same way in the voltage that you use every day, and you're not even realizing it. So stuck in the common understanding of it, you haven't opened your mind up to understand it in a different way. Temperature, frequency, all matters. Amperage. So if I wanted to create more amperage, what do? I put heat in the system. The more heat I can put in that system, the more amperage I'm going to get out of it. The less heat I put in the system, the more voltage I get out of it. So what's the transfer? If I want to transfer from voltage to amperage, I need heat. Now that we understand that a little better, we go back to Edwin Gray. This field right here, he's field flipping. He is literally putting heat into this system to convert that radiant energy into an amperage field. Once he gets the amperage field, he then goes along and runs his motor. Once he takes his foot off the gas, all of this right here goes in at a higher amount. It's always continuously going in there, but in order to get the higher amount, he has to let off the gas and just let this thing build up as a radiant energy field. Now, I do tests on my channel. I take my Tesla coils and I run them with the rod down the center. And then I put it to another Tesla coil and can convert it back to a magnetic field. That's how I know this is happening. This is how I know it's flipping from one field to the next. Interesting fun fact about radiant energy in the negative, it creates structure and holds in any kind of static or magnetic field. Interesting fact about it, huh? Not a lot of people would know that unless you actually ran the gravity flyer test like I did in reverse. That's the only way I found it. But I did find it and I did understand it. This is free energy right here. This device works. I could tell you this part right here, I had zero problem building. Zero. I could do that in probably 2 days. I can build this out and add the amperage field in because it's simply just a battery, to a switch. Go, 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 and get that. The hardest part about this whole thing is just building out the motor part. That's it. And I'm sure there's a lot of people out there that build motors who will tell you that's really not that difficult at all. It's the understanding of how this works. This is free energy, guys. This has been built a long time ago. The only reason we didn't understand it yet It's because we didn't put a rod down the center of our Tesla coil and understand that we were flipping fields. Now that we do, we now have free energy. Guys, please, build it. I'd love to see a bunch of cars that run on this. We'd actually get somewhere good in this world. Before we get out of here, all right, guys. Pretty interesting stuff, huh? Takes a little bit of understanding, and then we got it. You see, they all talk about radiant energy in the patent. They don't understand it the right way. They keep thinking it's like positive radiant energy, and well, you have to flip the field. Now, what I did not see in here was the diodes to flip it to, DC field. I imagine he had them in there, but it wasn't in this part of the patent. So if there's an extension to this part of the patent that actually shows it, then that's cool. But I didn't see it in there. I could tell you the field itself, once you hit the extra energy in there, it's going to have a ton of amps. It's going to be hot. Because as soon as you flip that field on the Tesla coil, man, that sucker gets hot quick. So it actually brings down the frequency quite a bit. So you say Tesla coil, super high frequency. Well, it really depends on your windings that you put into that coil that he built. So, yeah, I will build that part right there. That the gray coil, I will build that and put it on my channel. That's for sure. And I'll tell you right now, if I flip the fields on it, there's a no-brainer that we could put the engine to it. So I want to build Mike Faraday's motor, his Renegade, and we'll test it out on that. Just small little pulse motor, and we'll flip the fields. We'll build another part of the motor to it, start flipping it. Guys, if we have it, we have it. I mean, that's as simple as it gets. We'll just build it, make sure that it works, and we'll go for the gusto. I mean, I don't see any reason why not. We already understand the technology. We already have the Tesla coils built, so we understand the radiant energy. And I'm going to tell you this right now. For those of you who think I'm talking about the positive radiant energy that comes off the Tesla coil, please understand this. I am in no way talking about that whatsoever. I'm talking about the negative radiant energy that we found out of the Tesla coil by putting the rod in the center. They are two completely different fields. They build out the same in Scalar, that's for sure. But they're two different fields. They do totally opposite things. Now, if you can understand that by doing the simple test with the Tesla coils, we are in business. So, guys, I love free energy. You know what I mean? This is so cool. And then what I'll do, guys, is, hopefully I can start putting this stuff together and put it into one giant video. I got a couple more that we deal with cold energy. You know what I mean? And every single one of them that we can understand, there's one trait to all of it. There are no resistors in the main operating circuit. You see, that's the big key and giveaway. Every time I've seen one of these cold energy circuits that goes for a patent or wants to show you that they're free energy, there's no resistors in it. There's coils. There's multiple coils. There's no resistors. They do not use a PMP to get to a resistor. They always use an NPN, and they run it backwards to the negative. They pull it to the negative with a draw. They put a hot draw on the other side, and it pulls the energy through the circuit. It's the reverse, guys, of what you think it is. So I've seen it from the greatest inventors of our time. Linderman himself thought it was going to the positive side of the field. He did not understand that it was going to the negative in some of his stuff he's looking at. Had he known that, would have changed his opinion completely. He would have had this stuff a long time ago. Guys, we're on it now. You know what I mean? We're right there on that cold energy, man. So I'm excited to see it. Hopefully you guys all like the video. I'll put it out, as a single presentation for everybody if you guys want to see it. But yeah, it's awesome, man. That little car. So I'll go ahead. I just want to play the little car for Ben one more time. I'll let you guys know. Get it right back there. Give me a second.
Beautiful automobile. You can drive it anywhere you want to. You don't pollute the air. All the other electric automobiles that I've actually seen has been nothing but this standard transmission. This is an automatic transmission car. There's not a whole lot of what you call junk, I would call, under cars. I've seen a lot of electric cars that had a lot of stuff in it. The only thing that this has a battery to run the radio, the blower. We've got two safety switches over here that can be mounted into an enclosed system, but we did this where you could see, where people can see this car with the technology. It's a safety switch system. This is a controller box, a Curtis control box. It cuts the amperage down. So with the amperage, here's what's real good about electric automobiles. All electric automobiles that has surge technology with this in it, they create heat. They've got to have a fan to blow this Curtis controller off because it gets hot. We don't want that to get hot. We want to stay that cold, because once it stays cold, you save on all.
Do you hear what he just said? I just want to make this point and I'll let it play the rest of the way. He wants to keep it cold. He doesn't want heat in the circuits. That's exactly what I just told you guys. In no way does he want heat in the circuits because he knows it's going to last longer. He's doing cold energy for sure.
All the computer chips that's in this controller. So that means you can go farther, longer, and you don't have no problems. This electric automobile has got two gauges in front of the shifter on the automatic transmission. It's called the voltage and the amperage. That's what I was talking about earlier about amperage on automobiles. Let's see if we can't get the amperage to go down instead of going up. The voltage on this here should say somewhere around 120 volts. When we start out, there's no amperage at all. So the gauges is down below here, and we're getting ready to take and go drive the car, and you can see for yourself what it does. All you do is just take and put it in gear, and the motor sounds like a little sports car. Shifts, runs good, fantastic automobile, drives. If you'll see the amperage on the gauge, see it going down? Amperage goes way down. That's what I like about electric cars. If you floorboard the car, the most it will do would just be about maybe 100 amps. And that's what we want to do, is to keep the amperage down on an electric car. So it'll go anywhere really anybody wants to go. If you want to take a trip, you don't have to worry about it going to go plug it in the house, because it's called the surge technology. It's a beautiful automobile and I love it, and I've put a lot of hard work in this car, and we're going to make it. No oil, no gas to fool with. And the technology is here. It's going to be here. It's going to go. It's going to work beautiful for the whole world, for mankind. See you around. This is your future, people.
That's so awesome. You know, I think you guys all picked up it in the chat. Keep those amps down. So if he's converting the amps on demand, it keeps him down, right? Because he only needs it to drive the motor. Then when he lets off the gas, there's no more amperage. That's a dead giveaway of what he's doing. He's got to flip the field to do that. He's got to be able to pull that amperage back and get rid of it right away and be able to pull that back into radiant energy. That's not hard. That's something that we already do in our Tesla coils, guys. We've already gotten there. Once we converted that field back to the hot side, it was game over. We already knew what was going on. You see, he understood this, and he built the motor based on it. He didn't just build one, by the way. There's other videos out there of him building another test motor, which he just unplugs from the wall and it runs itself. Well, you're only doing that when you know how to flip a field. Pretty simple. Takes a long time to learn it if you don't know it. I got lucky and ran across it based on another experiment, and I've used it ever since. True insight, man, is doing it yourself. I'm going to tell you this right now. From my experience, running this energy is so much different than any other energy. I mean, look, stupidly, I put it in my burrito and it lights it up 3 feet away. What kind of energy do you put in a burrito? You put it into 4 of them in a row and it'll still run right through it. You put it into mud, it makes the mud conductive. You put it into sand, it makes the sand conductive. You put it in a 10-foot by 10-foot pond, and guess what happens? The whole thing starts to light up light bulbs. It's a crazy energy that's completely different than the hot side of energy. I want to puke my guts out when I use the hot side of energy on a Tesla coil. It absolutely makes me sick. So this stuff doesn't do that at all. It's completely different. Like I said, it's the opposite side. It's not the positive side. We all understand the positive side of a Tesla coil and how it lights up light bulbs and what the field is. And if you have it way too high in the room, everything that you touch will burn you. Everything. I can't touch my power source when it gets too high. It'll burn me. The other side of this doesn't do that at all. You can touch anything. Touch the water. If you want to put it in water, you can touch all the metal in the room. You have no problem whatsoever with this energy. It does not have that effect. Completely different energy field. I get a lot of people when I tell them it's radiant energy and they go, oh, well, you mean the outside of the Tesla coil? And then they base their answer based on that. Couldn't be further from the truth, guys. Couldn't be more far off if I, you know what I mean? Might as well be standing out in left field at that point because you have no clue what's going on. So just to tell you guys, it's a different field altogether. That's all I'm trying to say here. So we got some cool things, man. Yeah, and by the way, temperature flips it. It's cold, so it's room temperature and below. So we'd probably drop like 5-10 degrees. The cool thing with this energy, though, just so we understand each other, once it's dropped below room temperature, if you can keep it there, the energy keeps building. You see, it's the difference between the sides. The hot energy or the positive energy, just waste it. Just complete waste. When I put this in my rodent kill and I keep it 5 degrees under the temperature of the room, that thing will keep running. It'll have energy in it for as long as it stays down under that number. It continuously runs. So when we look at this kind of stuff, we have to understand when you do that test, when I put it to my Tesla coil and I just pull the wire out and that sucker's still on, we're playing with the temperature in the system. Now, everybody's dream is to play with the temperature in the system because that's the key to getting your energy free. That's it right there. That temperature is so important. That's why I keep calling it a scalar field. Now, I know everybody's going to say, no, Nathan, it's a magnetic field. It's a magnetic field, old man. Come on. We all seen it's been that way for years. I'm going to tell you right now, it's not. And I'm going to keep saying it because it builds out in a very specific way. And I do my test based on something simple. It better build out the right way. If it is how you explain it is, when I build it, it better work that way. And if it doesn't, we have to change the definition of it. So, very interesting, guys. Very interesting. We got total different energy going on. We're flipping fields. We're able to produce what we want. Love to see if there was a full bridge rectifier on the other side of that. I would imagine there was to pull it into full DC onto that motor. But think about it. If you're only putting in the energy on demand, right, in the amp side to get the motor running so that you can drive, that's pretty simple. We do that in Tesla cars right now. But the other side, being a generator, pulls in the energy as potential. You see, then it flips into the radiant side. We create a big radiant energy out of that potential. Sorry. That's pretty simple, guys. That's an easy conversion to do. Then we take that radiant energy, we add some heat, we convert the field over. This is why I have not done my conversion yet for my Tesla coils. Ian has, and he's been working diligently on it. He's doing a good job. I haven't done it yet because I wanted to do this, the Edwin Gray first, because his device gives it to us and flips it, and then we're able to use it. So now we can look at it and push it through. Guys, this isn't much different than Don Smith, okay? What is the difference here? Don Smith has multiple coils working on resonance. He's using resonance in order to power things. He steps it up, he steps it down on the coils, and based on the frequency that he creates, which, by the way, is probably divisible by 2 on each coil that he does. So radio frequency is very simple. If I create something at 200 kilohertz, then at 400 kilohertz, it'll also run that same frequency. Now, it won't be as strong, but it will be on the same level. Okay, it's just how frequency breaks out. It's your harmonics. Okay, one here, like a little wire. Okay, it's like this, like a little football. And then another one, or you go one big one. So it's your basic harmonic scale is what he's working on with the radio frequency. So Don Smith isn't much different. There's a lot more heat in the Don Smith experiment than it is here, but it would also work out in this experiment here because the heat would turn to amp. So yeah, they're not all that dissimilar, guys. A lot of this stuff is the same thing. You just found a different way to convert it, different way to look at it. Yeah. There's also another one out there, and I cannot pronounce the name of it. I believe it starts with a K, and it's doing the same thing. And it'll absolutely amplify when you put the wire back through the center of it. That's why he does it. He knows that there's a radium field there, and he knows he's going to capture it. So anyway, guys, it's pretty interesting on that part of it. I absolutely love this. We're on our way to free energy now. So I wanted to show you guys some other cool stuff while we're waiting for Ben to get back. I did some tests on my Tesla quad. I don't know how many people saw it, but I want to show it to you anyway. So give me just a second to pull it up. And here we go, right here. Check this out. I got this thing going. Look, I have my original Tesla coil running. I now have plasma discharge here, down there, over on this one. Oh, man. That means I'm putting out a mass dose of energy there. Look at that. Oh, my God, that's bright. Oh, wow. Oh, yeah, baby. That's the way it's done. That's so cool. It's picking up the energy and driving it right through that coil. No better way to see it than that. I know the plasma discharges are small, but so is the original one. So let me get around here so I can show you guys. What, 12 volts? Look at that. 355 to 358, somewhere in there. It keeps going up and down a little bit. But man, it's resonating really well. Look at that. That is so cool. Yeah. I don't know how much power that's putting off this. Look at that. Play Darth Vader all day. Vroom, 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 vroom. Sorry. Late at night, having fun. That's so cool. We're even picking up energy on this coil. It just keeps building out. It's like a null zone in these coils when they do this, so. All right. Enough playing around for now. Hope you guys enjoy this. I'm certainly enjoying it and having fun. I'm certainly enjoying it and having fun. Anyway, what I thought was really cool about this, guys, is we have no wires attached to those other coils, by the way. Just so you know that. They're simply just windings on a 4-inch diameter PVC pipe. That's it. I wound them to be the exact same frequency as the main coil. As you can see, there's a bit of PVC hanging off the top of the main coil. Funny story, I wound it and was off, and I had the frequency too low. So what I had to do was remove some windings from the primary coil there in order to pull it into resonance. So I have a bunch of windings sitting on the ground next to it as I'm doing this, and I'm just cutting it off little by little and removing some and bringing it right into the frequency resonance. I knew where it was. I used the cap bank that Ian sent me in order to find it. I knew it was at 361, and I needed to get there. So I started out at 330 on that main Tesla coil, pulled some windings back, frequency went up, and I was able to pull it right in resonance. So when you do, it makes the breakout. So let me just ask you guys out there in the chat, what do you think? Is it the magnetic field that drives it to make the breakout? Or is it the resonance? Is it a combination of the two? It's always an interesting question when you run across something like this, because hey, you simply put frequency into it. That's all you did. You match the frequency and you expect to get some radiant energy out of it, right? That's cool. I kind of expected that. What I didn't expect was the fact that it started, putting out some plasma. That's what I didn't understand. I started going, hey, we got something here. It's giving us some more energy. Now, I know I've seen one that, Tesla coil went to another Tesla coil and it started a motor up. I go, wow, that's pretty cool. Now I can see why we have energy in there. I didn't even ground those coils, by the way. Yeah, just so you know. No, they are strictly just a winding sitting in a housing. They are nothing more than that. Yeah, it's like a tuning fork. They absolutely just pull the energy in. And I didn't even direct the sound. That's what's crazy. Like the little box on the bottom of the tuning fork, I don't have anything shooting at each other. It's not doing that. You know what I mean? It is simply just ringing in the room, which I have trouble putting two tuning forks close to each other without that sound pushing at each other to turn them on. This was pretty cool that it did that. So I don't know. You guys tell me. I think that I think resonance holds a lot more energy than we think it does. And I think we give too much credit to the field that we put into it on the primary that goes out to the secondary. Now, it's still important, and I'm not saying to take it away. I'm just saying that the frequency produces a lot of energy in itself when it resonates. And we should all know that from building a Tesla coil. You have to put them in perfect resonance in order to get the fields that you want. So it makes sense that would be the case, right? But when you build something like this, it's always good to point it out, let everybody tell you what it is, and then, you know what I mean, we all reconvene and say this is what it is. So anyway, that's pretty interesting. I'll show you guys another one, and I'm sure you've seen this one already that I put out here, or maybe you haven't seen this one yet. So just give me 1 second to pull it up. And I put on the wrong video again. Okay. There we go. That's the right one. Okay, I changed some things in my setup. I went with a shorter number 2 coil here. It's down. Just so you know, guys, this was before the video I just showed you. So this is the precursor to it. Resonating at 340 kilohertz. I had to put a rod down the center over here change the frequency of this coil, but I got it all the way across the table now. So I'm still 20 kilohertz out of sync with this in order to get it right. And this right here, by the way, is the biggest hindrance. You see that breakout? You see, I'm at 11 volts. Problem with the DVS is I can't get it under this. So I may have to switch to the Slayer exciter because I can get down to 10, but I can't get it further than that. And that right there, that breakout kills your resonance. So I'm across the table now. That's a plus. I'll have to chop down the rod. I'll have to redo the math on the coil and make one more. But we're almost there. And I know that sucks to hear, but man, I really wanted to put this thing in right. The crazier thing is, like I said, the lower the voltage, the better it is for the resonance because you don't have the breakout. So anyway, just a quick update. Show you. Okay. So check this out. It's 5 feet away. There's no wires attached to that thing. Now, I put a rod down the center of it because I had to bring it in frequency. So as you add more mass in that one down there, I lowered the frequency. You see, I had to remove stuff from my primary coil in order to raise the frequency. So just remember that relationship. And the cool thing is it told me, hey, it still works in the same principle as your standard Tesla coil. When I put a rod down my Tesla coil normally, it lowers the frequency. So in a secondary coil with absolutely no wires attached to it, it does the same thing. That right there was pretty cool to understand. Every little thing that you can pick up along the way, guys, do it. That's why I do the experiments. Some of these things are never talked about. They say the answer when they write it down in a book. They don't tell you what happened in the experiment. They don't tell you the little things that are going on because it may change the answer because maybe they got it wrong. So it's always good to do this. So anyway, I got another one to show you guys. I'll stop showing that one. Let's see right here. I wanted to show you guys something, a little behind the scenes here. These right here are resonating Tesla coils. Each one of them has no other wires attached to them. Now, we've already seen that part. Okay. Let me get to some understanding that we should understand. And it has to do with resonance and frequencies. Now, I am forcing this coil to resonate right now. And what do I mean by that? Well, here's the number right here. I need to hit 361 or right close to it, 362, 363. That's where these coils resonate at. What's the problem I'm having? When you take this coil right here, it doesn't naturally resonate at that frequency. So I'm forcing it in by changing the capacitance in order to do it. But what if I just ran this thing at natural frequency? You see, the other coils won't pick up at all when I put it in the natural resonance. But the amount of power I'll get will jump. So I'm not going to touch this oscilloscope at all. All I'm going to do is change the resonance through the capacitors. Just watch. It's going to jump off the scale when I hit true resonance. Look at that right there. Now, I got a lot more power out of that, right? And right now, a very, very small breakout going on because we are at 11.7 volts. So those all turned on at that voltage, but my frequency sucked. So what am I trying to show you here? This coil here needs to be redone. It is resonating. Sorry. 255 right there. Why is that? You see, not a lot of people talk about this because I don't know if they understand it correctly. When you put two coils in resonance, the number 1 and the number 2 coil, what starts to happen? The frequency will drop. Now, each one of these coils, keep in mind, they're all built exactly the same. 361 is what this should resonate at, but it doesn't. It resonates in the 255. So as I build this coil next time, I have to keep that in mind. I am literally going to drop 100 kilohertz when I put it in resonance. Now, there's a math calculation that everybody should learn. This is not what you think it is. You see, if I drop this right here and put it in the correct frequency the first time without manipulating it, I get this. You see, I need the resonance itself to amplify just like that. I am so far out of resonance on this, it destroys putting this at distance. So the understanding is this: I could take out those 2 center coils if I put it in the correct resonance. Right now it's not, and I'm forcing it in there. If I want distance, that coil must match the resonance frequency of this, not the actual coil itself, but what it makes in resonance. So if I were to do this project again, you build this coil, you build each one of these coils to resonate at the frequency this one resonates at. So I hope everybody understands the difference here. It's not so much the power you put in. I think everybody gets the misunderstanding. We're not building a field like this. That's not what we're doing. We're taking this and we're simply ringing it like a bell. And as we're ringing this bell, these other bells should turn on. Anyway, I just wanted to show you that when you get things in true resonance, the power level goes down, by the way. It doesn't like the high power. It likes to be at very low power when it's in resonance. Then everything else starts to work properly. Anyway, I just thought you would like to see that behind the scenes and under. Okay, so I had a question about a top load. So in this experiment, I was trying to avoid putting a top load in and putting a rod down the center of my Tesla coil. I wanted to show just resonance across the board when you build a primary resonating Tesla coil, and then you put basically secondaries out there that aren't attached to anything. That's what I try to do. But yeah, you could put a top load on it and it would probably bring your resonance frequency back up. Okay. But again, I was trying to avoid that. I just wanted to build it this certain way. Find the sweet spot. That's right, Ben. I keep telling you, put things in resonance. So I'll show you one more, guys, and hopefully Ben will be back. I wanted to show everybody this. These are my Tesla coils resonating. As you can see, the lights here are turned on. That's not the impressive part about this. You see, this Tesla coil is the only one plugged into anything. These are simply just receiving coils. No ground, no power, nothing. They're simply just wire wound on a simple pipe, and they're taking in the frequency of the primary coil here in order to resonate each one of these to turn on the light bulb. Now, I'm going to turn on the lights, and I'm going to show you that they are attached to absolutely nothing. I need a closer light switch is what I need, that's for sure. So as you see, I didn't move the camera, I didn't turn it off. I want you to watch. As you saw, they're not connected to anything, but they still power up. Watch, I'll turn off the lights one more time and we'll see them on. Last one's always the most finicky. Not attached to anything. Pure resonance. From one coil to the next, to the next, to the next. Powering light bulbs at a distance. With everything just not attached to any wires. Here's the thing that'll get you. Let me turn back on the lights and I want to show you this. Guys, real quick, I just wanted to, right here, add a conductive sphere on top of the rod capacitance, yes. So one of the ideas here is very simple. Get them all resonating the same. Now I have equal parts to work with, right? So if I build one top load for one, I'll just build them for them all, right? So then we're set. If I put a rod down one, I put it down all the other of them. I want to make sure that it builds correctly. You see, I don't want to assume something and say they will based on this test alone. I want to be able to put a rod down each of them that's equal size, equal, width or diameter, and I want to make sure it all builds correctly. Once it does, then we start playing with it. Can I add an extra cap between the top of the coil and the bottom of the coil? Can it produce my energy that way? That's an interesting one that I heard. Top load as a sphere. Absolutely. We can get 360 degrees of energy coming out of it because there's a null zone at the bottom of a normal Tesla coil. And then, you know what I mean? Can we put the rod down the center and we'll pull the negative energy the same way? Or do we need the magnetic field from the original number one coil that we get normally produced? All those are valid questions, guys, but all of them have to be answered in what we do. So that's why I wanted the number one, let's put them all in the right resonance. Let's make sure they're all the same every time I turn on the Tesla coil. Then we'll rebuild them out and see where we need to go, right? That makes perfect sense. Let's see what the distance we get. We saw 5 feet. That's not a problem. Resonating in frequency will do that. So we also proved that we can resonate the secondary coils from one to the next and the next. So when you look at it now, I have the primary coil on. It resonates the first Tesla coil here, and then that one resonates the next one, which resonates the next one. That's why I wanted to do the test in this way, because it's proving out a theory of, hey, if you put these things on telephone poles or whatever, you know what I mean? Can you get them to light them up all the way down the line? Well, it has to do with the frequency being just right and the distance. That's it. Simple calculation. Once you understand it, build it out a little bit. We could just simply put it into a math formula and do the math, and we should be okay. But again, we got to be able to build them right. So that's why I did it this way, and I wanted to show everybody, hey, you pull the coil out. Make sure you understand I'm not grounding it, which grounding it gives you more distance, by the way. But I didn't do that, and I just wanted to have no wires attached. No games, no funny business, no coils anywhere hidden. It wasn't the table that's resonating. I can, if I drop the frequency a little bit on these coils, or excuse me, raise them up a little bit, my body can act as capacitance to turn these things on. And I've done that test. So now we have a basis of understanding we can build from. That's why I wanted to do it this way. It's just much cleaner. It's easier. We can figure it out. We have plenty of coils to play with and start moving things around. But yeah, I do want to put my Slater exciter on this. And I have the best Slater exciter. I can drop that sucker down to 5 volts and it absolutely will ring all day long. I can put it up to 40 volts and it'll do the same. One thing I did notice, by the way, is when these things get too close, it's just like your body putting off a field. It bounces the field back to the original Tesla coil and ruins it. So there is a certain amount of distance that you have to have. Also, if you put the ground wire to it, we can get an easy 4 extra feet out of it. So it already did 5 feet without any wires. If I connect the ground to it, I could pull 5 feet extra, 4 feet extra, no problem. But that wasn't kind of the point of the test. So I was trying to finish out what I was doing here first. All right, Ben, are you back, buddy? Maybe the resonance of the wire has to be. Yeah, I absolutely did. Look, I figured out what the ones were. I ran them on my frequency generator with a 20 k ohm resistor. Figured out the exact amount that's in there, and then I worked backwards from that. Went back to the original, found out I built the first one wrong. There's no question about that. I built it wrong, and then I turned around and built a second coil in order to build it right. And like I said, I was pulling those windings off, and I was like crying in my eyes because I had hand wound these things, and I'm like, man. All that work just to throw the coil, the windings away after I put it on there. But I got over it, manned up, and just did it. It just sucks to ruin your own work when it looks so nice, but you have to do what you have to do. So, all right, Ben. See, you back? You there? I don't think he's there yet.
Sorry, I was muted. No, I'm back. I was just waiting for you to add me. That's all. Because the admin privileges changed, so I can't add myself anymore.
Yeah, I sent you the email. Hopefully, you already figured that out.
Oh yeah, that's you did send me an email. Is there a way to change that? I think you mentioned that. Hold on, let me read that email real quick.
Once you accept it, you can pop out, and pop back in, and then you'll be all right.
Oh, okay. Well, we'll worry about that some other time then. I just have a quick update.
Okay, well, go ahead. I mean, my thing.
Yeah. So, as you know, I ran another test with the 0.6 watt LED, and got some really good results. So I'm going to go over those real quick, and then I'm going to go over the new open circuit PCB I put together and the results of that. Let me load this video real quick.
Oh,
so
real quick, I just answer this question. You ever hook a microphone to your Tesla coil? So Ben will tell you, when I do the test live, the sound that comes off of all this stuff is outrageous.
Yeah, it's really wonky. Oh, just by the way, Nathan, this video does have high pitched sound. I don't know if you have to adjust your volume.
Thank you. I'll turn it down.
Yeah. So you will hear the light bulb singing very loudly in this video. You just have to load it real quick. It's only a couple seconds. I think it's like 30 seconds long. It's at the bottom of the screen. I preloaded it.
Oh, sorry.
No, it's okay.
I forgot all about it, Ben. My fault.
So you hear it's kind of loud. And we're measuring the current while it's singing with the negative load wire connected. It's registering around 78, 79 milliamps coming out of the battery. And then we get about 7 to 10 coming out into the load. So a lot of that's wasted. But notice I unhooked that negative wire and it goes down. So it kind of matches the load now. So everything's kind of stabilizing. It stops making the noise. It's only when this is making noise that the current seems to peak. I think that what it's doing is it might be taking the frequency up to an inaudible range. You know, not that it's not singing still, but maybe it's just not in an audible range anymore. But we have some conflicting data. So what I mean by that is what I'm observing versus what we should be seeing with like the waveform is kind of backwards. And you probably have an explanation for this. But as of now, I'm kind of stumped. But I'll get into that in a second. So let me load up my notes here. All right, so in recent experiments with the Joule Thief circuit, the lightning thief device that we're working on, I observed unexpected and opposing behavior from what is typically expected in such systems, particularly related to the negative load wire and the waveform that we're picking up with the negative wire connected versus it disconnected. So these findings significantly impact the efficiency, the waveform characteristics, the duty cycle, and the behavior of the voltage readings. So the waveform observations with the negative load wire connected, I noticed it produces like the sharp pulsed waveform, and I'm going to load it up in a second for you guys to see. Give me 1 second. Actually, let me do that now. I'll give you a picture so you have a visual. All right. Can you see that?
Yeah, I see it. So
Okay.
that's what you're getting out of it?
Yes. And keep in mind, this is not picking up the negative right here because we're floating the negative on the probe, right? So we're just hooking this up to the positive output of the load for the Joule Thief circuit. So what's going to the light bulb, basically. And this is what's picked up with the negative wire connected with it singing and the efficiency a little bit less than what it was with the wire disconnected. So this is more registering kind of like as a pulsed DC almost, it looks like, more than a sinusoidal. But I thought that was very, very odd because when we actually disconnect that, it turns into more of a sinusoidal wave, which I'll show you here, which is the opposite of what you would think when it's in resonance. It should be more of like an AC, right? So I don't know. It's very weird. Again, my oscilloscope isn't the most accurate. But yeah, you see the clear negatives here without the again, this is still floating, the negative probe. So this is very weird behavior for the system.
So hold on. You're getting a semi-sine wave without the negative in it. That's what you're telling me?
Yeah. Yeah, like when it's connected and it's getting a little bit less efficiency, it's produced like the pulsed, you know, kind of like a half sinusoidal, and it's not picking up the negative here. But when I disconnect that, it's like it's picking up the rest of the waveform. It's really weird. So I don't really understand it. I'm sure there's an easy explanation for it, but as of right now, I just don't have anything that can explain it.
Okay, so let's go back a minute. You're running DC through your system?
Yes, but the Joule Thief is supposed to oscillate it So technically, when it's in resonance, it's supposed to show more of like a sinusoidal wave, from what I understand.
So you're putting in basically a modified sine wave, and you're running it through a coil, which mimics itself by the windings that you put in it.
Yeah, yeah.
So that looks like the right waveform.
Okay. So
It's bouncing off of the other wires, Ben.
Right. And like you said, it's saturating the coil now. So it's saturating the coil, and it's not wasting any of the amperage. It's bringing the amperage draw on the battery down to what it should be, the minimal, you know? So that's pretty cool. The efficiency appears to be lower when the circuit sings, indicating, the singing indicates resonance, but, it appears to be lower when you can actually hear it compared to when you disconnect that negative wire, it stops singing and it becomes a lot more efficient. With the negative wire disconnected, it generates I wouldn't say smooth, but more of a jagged sinusoidal wave showing both positive and negative cycles, which is very interesting because, it's not picking up anything with the wire connected on the negative, which is kind of cool. I think that's pretty telling of the system doing what it's supposed to be doing. But the efficiency improves despite the oscilloscope reading a much lower DC voltage. Now, this was interesting because the DC voltage, when you disconnect that wire, it drops, and it's no longer registering as it's stepping up the voltage, which is interesting. The voltage registers as DC instead of AC at this point, which is very unusual for a resonant circuit. Again, I'm sure there's an easy explanation for this. But when you disconnect that wire and it produces the, sinusoidal waveform, you can't pick up the voltage on the output of the load as AC anymore. You pick it up as DC, which I thought was really weird.
Why would it be weird? You put DC into it, right?
No, because we're picking up a sinusoidal waveform, right? So it should be oscillating.
Modified DC.
Oh, so it's a synthetic? Are you saying it's like, okay, so it's a modified. So that was something in my notes too.
Yeah, it's not a true AC waveform.
Okay. Yeah, no, that was one of my
DC.
Yeah, that was one of my next theories that I was going to get into, is maybe it's like some kind of synthetic DC or not a full AC form. So yeah, that pretty much then aligns with one of my theories. But the duty cycle is also significant because it was my impression that the duty cycle would drop from 80% down to like more 50% when the circuit approaches its optimal operation, like a sweet spot. And that's exactly what happened. So yeah, that was pretty cool. We did see a drop in the duty cycle, indicating that the system is kind of stabilizing. Like everything kind of points to it kind of stabilizing out. So disconnecting the negative wire results in higher efficiency, which is, interesting. The circuit operates more smoothly without the characteristics audible resonance, suggesting a shift to a more pulsed DC mode that simulates AC resonance. And that's kind of like what Nathan touched on as maybe what's happening here. Open circuit test results, though. We do have some results that I'd like to close this short presentation with regarding the open circuit. So up until this point, as you know, I've mentioned before, the PCB for the Lightning Thief has two modes. And up until this point, we've been only using the closed circuit method. Now, I just recently got some new transistors and put together a PCB for the open circuit method to test this. And we got some very interesting results. It's extremely efficient. I'm talking extremely efficient. So without going into too many details, because I don't have all the data organized very well, this is just something that I put together right before the stream. But the theoretical 100% draining of our battery for this load, a 0.6 watt LED, should be about 0.03 volts per hour. Okay, and this is what we've seen around this drainage, only a little bit more efficient with the current test that we're doing with the closed circuit. Now with the open circuit, we get around 0.0058 volts per hour drainage. So I think that is an extremely successful test. although it's not picking up, it's not stepping up the voltage enough to actually light up the neon lamp, which is interesting because usually, you know, these circuits, they'll step up the voltage. They'll take that 12 volts and turn it into 120 pretty easily. This isn't doing that. It's keeping everything at a minimum. And on top of that, I'm not able to register any AC current. Now, I haven't measured for DC current yet, and that's what I'm going to do next. But yeah, it's very interesting. So it's working, but it's not doing some of the things that we've seen in the closed circuit. So some hypothesis for some of the behavior that we're witnessing is maybe we had an impedance mismatch for the wire connected versus disconnected. We could have some kind of capacitive coupling effect, or maybe a phantom ground effect, or you know, just a shift to a non-oscillatory form of energy transfer. So there are different potential things that are going on here, but I think the most important thing is the shift of efficiency in the system, and that is clearly observed to this point. It's pretty cool. It's lasting a long time.
What I would see, Ben, is if you know, down the road, if you can get some piezo buzzers,
Yeah.
like this on the negative side, just run them right through the negative. Okay.
Mhm.
So just connect one side, which is the positive of the piezo, to one side of the negative, and then the other one, just like you're running it right through it, right?
Mhm.
And then let it pulse itself. So when it pulses, it should amplify. You know what I mean? Right afterwards on the negative side.
Right.
Then you should be able to pull some extra energy. That's what Mike Faraday is always talking about.
Yeah, I think that's a good next step. To squeeze a little bit more efficiency out of the system, just an easy method to do that. I'm sure there are different ways to do it, but you know, I think that's probably going to be the easiest way at this point to kind of squeeze it a little bit more.
Well, he also talks about the load. So you drop it into a capacitor bank on the outside, so it has the draw, so it pulls it through, but then it hits the piezo and amplifies. So every time it pulses, it's like a 1-2, 1-2.
Right.
Man, should start to amplify your system out.
That's cool. No, and then I talked to Mike about potentially, and I don't want to do this on the consumer version of the Lightning Thief because I don't want to have like a spark gap in the Lightning Thief board. I want it to be, you know, easy for tinkers to get in there and work with. But like I am considering building a version with a spark gap instead of a transistor, just to see what kind of efficiency we can pull out of the circuit, you know?
The spark gap will add an extra little bit of energy to each one that you do.
Yeah, so it might just increase it slightly. It's not going to be like an exponential.
Well, it's going to take away the heat from your transistor.
Yeah,
you won't ever have that again.
Yeah, I'm sick of blowing up transistors, man. I go through them all the time.
Pretty much a non-issue at that point. The spark gap either works or don't, and then you adjust it again, and it works or don't. You know what I mean?
Right.
That's why Mike likes him. He hates blowing that stuff up. He's not like me or you. You know what I mean? We fry stuff all the time.
Yeah.
He ain't into that.
Well, I think it'll be fun to test with. You know, the I at this point I just need to stockpile some transistors though. Specifically, I'll be working with the MJL21194, I believe it is. And then the one that Gerald recommended, the MJE13009. So those are the two ones that we'll be working with this one. But of course, you guys can try out your own transistors when you get the device and see what happens. Because Michelle and I are getting radically different results with our transistors. He's testing with the what did I say? The 21194 transistor, and I'm testing with the 13009. And it seems like I'm getting a little bit more efficiency out of my system.
Hi, Lulu.
Hey, Lulu, how you doing? Hey, Ian.
So check the rate of switching on both. I bet you they're different numbers. Because Gerald was talking about that earlier in one of his other experiments, the rate in which they switch.
I think you're right. Because I think the 13009 is faster switching.
Yes. That's what I was just about to say. Absolutely.
It has a different like trigger voltage or whatever, but that shouldn't matter because it's so low for both of them compared to what I'm doing. I don't think it should matter, right? I think it's like
No, it shouldn't matter, but it would increase the efficiency of it if it was faster.
right, exactly. And for the stereo amp board, Michel was I mean he came into a roadblock, and he's gonna have to kind of rework that a little bit because we had some problems with that board. We are intending to do that green machine board though, but the stereo amp is using 2 transistors and oscillating the energy back and forth between them, kind of like I think, doesn't Gerald do that with the dual transistors he has?
Dual transistors, they both oscillate, so it puts in a resonance frequency that runs, one to the next.
Right. So yeah, so that's always a possibility, just add another transistor and adapt the circuit that way.
He actually gets them to keep going for a while too. He turns it off and it just keeps running.
Oh my God. See, that's what I need. I like that, where you can turn it off and it'll just, because, the coil will hold a little energy and while it dissipates. That's so cool.
Well, he's dropping the temperature like I told you. He just drops the temperature a little bit. It keeps running until the temperature comes back to room temperature. His is all on the cold side, by the way.
And imagine the usefulness of that. So you have a self-recharging system, but it takes a couple minutes to recharge itself, right? While it's powered down, you have a little bit of residual energy you can still use, so your car doesn't completely just crap out on you in the highway.
Yeah, real quick, I use those health devices on my face. Zapper. See, that didn't feel any good, but it sure was fun. Oh man! All right, Ben. So, have you seen the egg story? You had
no, I haven't. Yeah, I haven't. I heard someone briefly touch on there's a new UFO video, but I haven't seen it. I haven't heard anything about it. So if you have an update on that, please, I would like to know more. Because I'm an egghead.
So you're an egghead. All right, so let's do this first. So this is his little car, right? And I figured if he's gonna have one of these, Ben's gonna want one, right?
Yeah.
Just like Gerald's scooter, you wanted one because it's electric, right?
Yeah.
So I didn't want you to go without Ben, so here you go. Got to get the team in there. Got our own little Geo Metro. Gerald's got a scooter.
Hey, we need a fleet of free energy vehicles. Seriously.
We even got a convertible, Ben.
League of Extraordinary Inventors isn't taking the public transportation, ladies and gentlemen.
Oh. All right, Ben, I'll kid aside. This is the UFO story, or the egg story, I should say. So, what do you think about it so far? They said they picked this thing up on a helicopter or something like that, and it was attached, and that's the size of it.
What exactly am I looking at here? Is that the ground?
On the very end, it just looks like a winded rod, and then it looks like just basically
an egg taped to a rod.
Yeah, an egg. So this is what they said it was when they did the news story. You can see it's from News Nation.
What?
So here,
it seems like there's not enough information. Oh wait, hold on. Here we go. Yeah, that looks like an egg. What? What? It looks like an egg with a piece of tape on it.
Oh, dude, they did 45 minutes of this story, and then they showed us this.
And a couple of strings. What? They put this on the news?
Yes.
Are you effing with me, Nathan?
No, I'm
setup?
Seriously not effing with you. Not at all, man.
Guys, you guys aren't pranking me right now because this cannot pass as a UFO footage. Like, this is just an egg with tape on it. with a couple of strings attached to the tape so it can hang. What? I saw that in 5 seconds.
Oh, dude, it's bad, isn't it?
This is terrible. If that's what they're passing off on the mainstream news, we have our work cut out for us, Nathan.
Oh, dude. I think they just wanted to prank us, Ben. And then
Maybe.
this guy's the guy that was
You know,
the
it
guy
could be a
that showed-
psyop, seeing how much people believe, how much they can be spoon-fed, you know? How much crap did the public buy?
Well, dude, this guy tripped me out. Like, if I sat across from him, it'd be a very uncomfortable situation. His eyes freaked me out. Like,
He looks intense.
yeah, I couldn't look at him. Like, if you start looking at him too long, I think I would, like, you know, change into something else. You know what I mean? Like,
Yeah,
he's gonna possess me or something.
Yeah, he looks like he's about to blow up the building.
All right, you say it's real. Yeah, it's real bad. I can see that.
Well, do we have any actual footage? Like, what's the footage look like? As still images could be a little deceiving sometimes. Let's see if there's footage. Maybe we should check out the whole clip. I don't know. I'm just trying to be partial or non-partial.
Impartial.
Yeah, impartial.
Yeah.
Sorry, impartial. Yes.
I don't know. Give me a second. And I'll put up the next one because this is what they run the story as, something like this. But that wasn't what we saw.
Right.
It's legit. I don't know how it's legit. I saw an egg just like Ben did.
Is this actual footage though? Is this actual or is this something that was created?
Oh, this is a joke that they put on top of it, Ben. This is a joke.
Okay.
Just like kind of this one.
Yeah. Oh my God. Egggate.
Yeah.
SG1. We're going to the yolk galaxy. Either that or a giant chicken is gonna like hatch. A giant prehistoric alien chicken.
Oh my. Oh, the rest of the clip, by the way, News Nation has been getting on people for playing it, so I didn't want to play it. But
oh yeah. If you're gonna get hit, don't. Well, I'll look at it some after the stream. But yeah, this is.
So I thought maybe it might be. Maybe there's just a little chicken inside, like you said.
Yeah. A little alien chicken.
Oh, man, I'm sorry. I'm just not buying this one. Look, unless I see an alien jump out of this thing, I'm not there.
Well, here's the thing. They could have very well, and this is not to say they don't have footage of an egg-shaped craft, but they could have very well played a psych ops and released some fake footage just to see how much we would buy, you know, how much the public could be persuaded at this point, you know?
Yeah, I mean, look, I'm all for it to change my mind. We just better not see a chicken come out or the yolk. Yeah, balloon, maybe a balloon.
Take me to your farmer.
Oh, there we go. There we go. There we go, Ben. It was Chinese the whole time.
Is that supposed to be
they're balloons.
Oh my God. These are hilarious.
We're getting invaded by the egg people.
Humpty Dumpty's wife is pissed.
Oh, that's bad.
Yeah, that's funny. I mean, it is worrisome though. If it's, you know, fake like it looks like, I don't know. It's worrisome that the news would put that out there. Meanwhile, we have actual footage all over our, you know, YouTube of actual crazy stuff that can't be explained. They don't show that.
Yeah, instead we get this.
Come on, man. That looks like an egg with tape. Let's try to recreate this. I'm sure we can recreate this exact image.
Oh, you know what? I have extra coil that was for my rodent coil. It looks just like that. We could just make the background green. I could get a couple of, little ropes, little strings.
Let's break
and
this
put
down.
it around an egg and put it in the dirt. I think we could do that very easily.
Yeah, we could do that. But let's break this image down real quick, okay? So if this actually is an egg shaped spacecraft, what is the purpose of the tarp over the top, right? What is the purpose of those two strings? And what the hell is that long pole? That can't be a part of the helicopter.
Well, it's like a steel rod. You know how they lower a steel rod down to connect it with a hook?
Okay. So maybe they're trying to lift it. Maybe they're trying to lift it. I don't know. It look like if they're trying to lift it, though, the tarp would be on the opposite side. It'd be on the bottom.
Well, I think they have one on both sides, Ben. Like a diaper.
A diaper. Look, I don't want to say that this is real or fake at this moment, but right now it does look like an egg with tape on it.
Dude, that's definitely just an egg. There's no way. I can't see the real footage. They gotta be really messing with us, man.
This is a deep state message telling us to go suck an egg, ladies and gentlemen. We're not going to do that.
Oh, you got egg energy transmitter.
Egg energy.
Oh, the tag was blurred out. There you go.
Oh, yeah,
This is
Stephen Gray
bad,
did mention
man.
something like that, didn't he? He said it was from Lockheed Martin.
This is, oh man, this is from like somebody's playground right here. This is what this is.
Hard boiled.
That's so bad, dude.
I feel like my brain is hard boiled after looking at this image.
Yeah. Yeah. I don't know why they even showed this. Like, I can see now why they had such a big buildup with the guy, right? They started talking to him, going over his life story, saying how credible he was. And then he started almost breaking down and crying. And, he's all religious or something because of this. And then they show the egg. And it was like, dude, what the fuck? Like, seriously? Like, what are you trying to pull over our eyes here? Like, you could have shown me alien ducks, and I might have believed it. Not this. I can't. I'm not buying into that.
The only other explanation that I could think of is they heavily put like these filters, these green, disgusting filters on it because they don't want a clear image of it. But I don't. That's like the least. I buy that theory the least. At the end of the day. I don't think that would hold up.
Maybe they didn't have a video, right? Just this guy coming in. They go, let's make a story. And then somebody in the background goes, hey, I got an egg. I got a diaper over here and some string. Another guy goes, I got this metal rod thing. And they go, oh, man, perfect. Let's use that too. You know what I mean? It was like the junk drawer.
That would be so funny. That's probably what happened. No, like we don't got no footage. Let's make something up. That's funny. Well, it's not dissimilar to what happened with John Hutchinson when he had the video crew come over. Nothing was happening because usually it takes a long time for something to happen, and then they're like, "Oh, let's fake some stuff just to get something on video."
Yeah. Joe says it's Mork and Mindy. Nanu, you know what I mean? That's so bad. He came out of
pop out of that thing.
Joe sent me an episode of that too, by the way, of them coming out of the egg back in the 80s, man.
Oh, they really had an egg-shaped ship in that show?
You remember that show?
I remember the show, but I don't remember them coming out of an egg-shaped ship.
Let me look it up real quick. Okay. I'll show you.
I remember Alf. That was a funny show.
Oh yeah, hold on. So there's a lot of pictures here. So I'll just show the whole. There you go, Ben. It's all about the egg.
Oh yeah. That's hilarious.
That's so bad, dude. Look, here you go. Right there to the right.
Man, they've been preparing for this psych ops for a long time.
But at least they had more coming out of the egg, right?
Yeah.
We didn't even get that.
Somebody at the conference room and for the deep state's like, sir, are you sure anybody's gonna get this reference anymore?
Oh, yeah. Oh, they got us pretty good with that one. Oh, that's so great. Oh my God. Okay. I gotta take that off of there. I just thought I'd ask you, Ben, you know what I mean? Because this stuff, this is just bad, man. Like, what kind of stuff are they trying to do to us? Like, we all want to believe in UFOs, or they just pranking us all, or what?
Yeah, it's either they're testing us to see how much we can believe, how much they can manipulate us into believing, or, it's some kind of threshold effect.
Jeez, man. Yeah, that was awful, bro. I mean, I'm sorry. Give me something better. Make the saucer shape. Put the egg in the saucer. You know what I mean?
Yeah. So at this point, the UFO, the controversy surrounding UFOs is still, stigmatized to the point where nobody is going to really, who's on the fence about it, is going to really buy the fact that that's a ship. You're going to have to release some actual like high quality footage or images if you're going to, persuade anybody, because that's just pathetic. That's like, hiring a kid to do, something that an adult should be doing.
Yeah. Like the whole military cam effect with all the green just doesn't work anymore.
No. It's, like that's, you need a high quality video or an image of one of these things, or you're not going to convince very many people who are on the fence about it.
Oh yeah. I I don't know, man. If you're gonna do this, at least something better. Anything better. Okay. That was a joke. I don't even know why they put that guy on.
I know the UFO community gets a lot of crap to begin with. We don't need this. You know what I mean? I don't need to be associated with this, whatever this may be.
Yeah, I give Ashton credit. I was watching a show, and he totally called it, man. He called it like it was before it happened. He knew it was going to be cool.
People need to call it out. Call it like you see it. Credit where credit's due. Credit to Ashton.
Yeah. So bad though, dude. Seriously, like, come up with something better. I'd love to see like at least a saucer shape, at least. You know what I mean? Make it into a frisbee and throw it into the ground so at least it looks like it crashes. You know what I mean? I bet you I could make better special effects than was on that picture. Yeah,
that's, I don't know. Like that's not going to convince me. If they had footage of it, maybe I could analyze the footage but just still images. That you need to up your game. If you're going to release something, honestly, at this point, I would have said it probably would have done less damage if he would have not just released those at all, and just came out with his story. You know what I mean? If his story is associated with those images, that kind of, doesn't do him any good with credibility, because people like me are going to be on the fence about that. Like that doesn't convince me of anything.
Oh, dude, I'm not on the fence at all. That was just awful. As soon as I saw it, I knew it was just like you. As soon as I saw it, I knew it was an egg. Dude, there was no getting around it. That was an egg. Like at least
I was like,
they
oh,
should've-
guys, we forgot to tell you this is a recreation of the footage. It's a guy, one of the camera guys, holding the freaking egg on a fishing pole.
Oh, the wild goose days. At least they could have got one that was about to hatch or something and put it out there, and you could see it cracking or something and be like all freaked out. The aliens are coming.
Oh man, that's funny. Well, I don't know what to say about that. Honestly, I heard Dr. Greer mention it the other night, though. He did mention an egg-shaped craft that they were talking about, but I didn't know what this is what they were referring to.
Yeah. Oh, that was it. That was their big reveal, Ben.
Well, that was a pathetic reveal. Show me something good. I want to see the seams of this thing. You know, I want to see if they have any nuts and bolts. You know, I want to see the details, the scuffing of the paint, you know?
Yeah, there you go. Put some orbs around it. Put some plasma orbs around the egg. Then yeah, maybe some swirls around it. Then we can get somewhere, right?
No, the news is just going to put the egg in the microwave, you know, with a piece of metal or something.
Oh man, you know, it reminds me of my junior high science fair program thing. I didn't do anything till the night before, right? So
it's the same way.
Yeah, I was being lazy, and I go, okay, all right, what can I do that's real fast that's scientific? So I took a bunch of beans and put them in the microwave, right? And then they exploded, and I took pictures of it, and I go, oh, that's pretty cool, right? So I go through and I'm exploding stuff in my microwave, hot dogs, everything. So it makes all the perfect sense, right? I light up my burritos now. I might as well have done it back then, huh? Yeah. My mom was so pissed, dude. That microwave was so dirty. Like
chunks of hot dog everywhere.
The beans just exploded like crazy. They were refried beans, and it was all over the microwave.
It was Bean-again.
Yeah. My teacher knew that I did it at the last minute. She gave me a C on the project, man, only because I made the whole class laugh because all I was doing was lighting up beans.
That's funny. At least you got some kind of humor credit.
Yeah. So I get for doing it at the last minute. I should have made it more dramatic, put some green light in there, and then I could have said it was alien beans.
That's funny.
Oh, man. That's just great. Yeah, I get in so much trouble as a kid, dude. I get in trouble now. You know what I mean? There's no getting around it.
Hey, we're all young at heart here. We're all just kids at the end of the day trying to play with their toys.
Yeah, that thing was a hoax, bro. Like, I want to see something better. I keep saying that, but I just anything. You know what I mean? They have the technology to do it. It's not like they can't lift the saucer off the ground. Why not just show that?
Oh, listen, it will come out eventually. Sooner or later, somebody's going to capture something, whether they want them to or not, right? Some kind of high quality video or image that's credible, right? And when that happens, we'll know it because the internet will lose their damn minds, okay? We'll see it blasted everywhere. But until that happens, you know, like this is just, you know, window dressing. This is nothing. So the actual reveal is yet to happen, but it will happen. I'm certain of it. Eventually, someone's going to capture something, or there's going to be someone who comes out with a leak or some kind of, you know, information. And it's going to be everywhere. It's going to spread like wildfire all across the internet.
You know, I'll be very honest with you, Ben. I don't think we're going to see it until we build it.
You don't think so? Well,
no, I have no faith because that's all going to be like this footage here, right? You're going to see a bunch of grainy garbage all the time. all you know what I mean, all you're going to see is green light, never regular light. You're never going to see it clear as day. It's always going to be an orb, some kind of light. You know what I mean? It's never
Well,
going to be.
I'm hoping somebody from one of these, programs, like maybe somebody who scrubs those photos from NASA, with somebody just, grab some kind of quick screenshot, some kind of quick evidence for us, please. We're asking you here. We're desperate for some real, evidence, because this is bull. It's bull crap.
Well, I'll tell you what, right now, if one lands in my front yard, we're doing selfies, man, and it's going on my page. You know what I'm saying?
Yeah.
We're hot rodding that thing around the galaxy, bro. There's no two ways about that. I'm making friends that night. So, yeah, but this, no. Like I said, I don't think we're going to see it till we do it.
We can do the CE5 app. I have the Greer CE5 app that, supposedly will allow you to, communicate and contact UFOs. So we could try that if you'd like one night.
Is that by psychic means?
Through meditation. So psychic meditation, like whatever mechanism you'd like to attribute to it. You do it through meditation and sound. Like you put out sound with the app. And there's a whole instruction list on how to contact UFOs and get them to appear, So I don't know. It was something that I always wanted to try, but I didn't want to try it by myself because I guess he says it works better when you're in a group,
So let me get this right. We do a seance, and then UFOs.
Pretty much. Yeah, pretty much. It sounds wild, but I'm open to trying it.
All right, well, when we meet up in person, we'll have a few beers, do some seances, and try to contact the alien.
If nothing happens, we'll bust out the Tesla coil.
If it involves me running around in my underwear, I'm out.
Trust me, we're not going out on a full moon. I'll check my calendar. Yeah, I'm open to it, but slightly skeptical, like most things. But it's something that I've always wanted to try, and I do have the app, so.
Yeah, News Nation Lulu was cutting down on us showing it, so I didn't want to get a strike on my channel or play with it. You know what I mean? They're just better off showing the still footage. So, yeah, but I appreciate the video. So Ben, you should have it.
Yeah, if she sent it to me, I'll check it out.
Yeah, so he says that they grounded on January 11, 2023 at 7 a.m. I saw it. So is this your personal experience with the UFO or is it the egg? Because I don't think they grounded anything for that egg. Remember Taryn's story? He said they tried to pick him up 3 times in the UFO, and then they finally gave up.
Wait, say that again?
Taryn Earthling?
No, I
haven't.
haven't.
He was telling us his UFO story a while back, and he said that they tried to pick him up like 3 times. He saw him. Maybe they tried to pick him up. He saw it 3 times.
The UFO?
Yeah, and he was describing it.
Oh, wow. Did he say if he thought it was, like the deep state or actual extraterrestrials?
We
didn't know.
I don't think he knew. We just saw it.
I couldn't tell at that point unless you're actually abducted, huh? So, no, I'd be interested to ask him about that because I know people who've seen things, and I have a friend who actually recorded. I'm going to try to find the video. It's on YouTube somewhere. He recorded a UFO outside of his window, and this is in Michigan, right? And he didn't know this, by the way. When I watched the video, I zoomed in and I slowed it down to a crawl on the YouTube video speed.
Mm-hmm.
You can actually see it. It's a gyroscope. It's rings spinning inside of rings. It's insane. And I'm gonna try to find that footage for you. But I mean, it's on his channel. I don't remember what it is, so I'll have to do some digging.
Well, that'd be cool.
Yeah, no, it was really insane because it's something like you don't think anything of it. It's just a dot in the sky that's kind of moving, and then you zoom in and you kind of slow it down. And you can see the consensual rings like spinning inside one another. It's pretty cool. So, And that's kind of consistent with some of the reports of UFOs. You know, they're some of them are gyroscopic shaped, you know, with rings.
Well, I want to see one. And maybe that's the problem. Maybe I should say I don't want to see one, and then one will pop up.
Mm-hmm.
You know?
Yeah, I don't know how it works. Honestly, I don't know if there's like you gotta get the right fortune cookie or whatever. But you get Chinese food tonight. Open your fortune cookie, and it's like you will see a UFO tonight. Yeah, hell yeah, that's what I want.
Aliens gonna come by to prank you tonight, Nathan. That's what it's gonna say. I get the land of the lost aliens. Remember those big-eyed people with the little horn on their head?
Oh yeah,
That's who will show up. I get the lizard people.
I made the extraterrestrials in divine science. They're all pranksters. They don't intervene in human shenanigans unless it's absolutely hysterical.
They pop up and I don't have a camera. Well, try to keep my cell phone with me, so hopefully that'll help. Maybe it don't even work, dude.
Yeah, and then you can't get it out fast enough, or you know your phone is like freezing on you. Every other possibility or variable that you drop your phone at the last second and it disappears when you pick it up.
No, dude, we're doing rooster tails on the lawn, man. If they ever let me drive, they're in trouble. We're rooster in everybody's yard, man. I'm sorry. It won't be a quiet night.
Hey, have you seen the control mechanisms for how supposedly some of these craft are steered? Like it's like a sphere, right? It's really cool, like really intuitive if you think about it. It's like a almost like a gyroscope in itself. You know, you can control with one hand the 3 dimensions of the vehicle, which is pretty cool.
Oh, you're talking about that little ball that they...
Yeah, the little ball. On? Yeah, rub your balls. Yeah, a little sign in the UFO that says, "Don't forget to rub your balls, pilots." Like some kind of acronym for remembering something.
Ben gets in the UFO, starts rubbing his balls and see if it'll make it go. Ben, I don't think it works that way.
Sir, that's the wrong ball.
Oh.
Man, this was a fun show. This show is hilarious. We had a lot of fun tonight.
I'm sorry, man. I had to bring it up, but that... Oh, hold on. Let me share the screen again. Sorry, you know me in the pictures. I always got to have fun, so I got to show it right there. So I put that up then because here I am thinking, right, we'd have all 3 of us in the car, right?
Uh-huh.
But then I thought, oh, Gerald is building that scooter that is over Unity, right? So even though he's Superman, he's got to have a scooter. He's got to have a moped.
That's what was making me laugh so much. He's Superman, but he's got this scooter. He's like, "I'll save you, Lois," and then he hops on his scooter instead of flying.
Oh man, yeah, it's so great, dude. We gotta have a little fun with everybody.
So, whatever happened to that guy, Edwin Gray?
He died. Mysterious circumstances is what happened. Or how do I want to say? Perfectly healthy and then dropped dead of a heart attack kind of thing.
Wow. And when was this? Like right after he released his vehicle, or was it like a little bit after?
He started getting a bunch of threats after he patented it and they approved it.
After he patented it. And okay, I gotcha. Yeah, that's usually when it happens.
They did not want him to put this out because that vehicle right there would be awesome, right? Not the Geo Metro, but he could have used a better vehicle. But
Right. That was just a template.
yeah, that recoil effect on that coil, man, that was something right there. Like anybody would like to have that right now. They always talk about, hey, put a solar panel on your Tesla, which wouldn't do anything. But this would do it. It's like an alternator running at all times, recharging the entire system is what it is. And it's free flow.
Yeah, and you wouldn't need that dangerous lithium battery bank that you have in the Tesla car. You know, the giant battery, you wouldn't need it.
That whole giant battery is a fire hazard.
Yeah, it is. It's really dangerous. That's like I was considering getting an electric vehicle, you know, like a Tesla for a while, but that just turned me off. I'm like, no way. That's, you know, a fire hazard, like you said. It's dangerous.
Yeah, I looked into it for my Chevy Nova that I had. I had a 72 Nova Blue, gorgeous car. But I wanted to put a electric motor in there that looked just like a regular motor. And there was a guy who made them, but he never got them out to the public. He kept showing them on the YouTube and everything and said they're coming soon. Well, then 2 years later, they're still coming soon. And it's like, dude, how hard is it? You put a casting together, polish this sucker up, put a couple of valve covers on it, and throw the electric motor in the inside. I mean, what's the difficulty here? Just get it done. So, but it looks just like a regular Chevrolet engine. It's just you'd have to take the trunk of your car and put batteries in it.
I'm wondering if maybe he got an offer from somebody to shut up.
Well, it wasn't like over Unity or everything. It just ran like an electric motor. It just looked like a Chevy engine.
Still, I don't know. It's competition, so you never know. Somebody might have bought him out.
Well, hopefully Chevrolet bought them out and made them look like that because theirs is really freaking ugly. I mean, you got a classic car.
I never liked the aesthetics of the Chevrolet, to be honest. Any of them. They've always looked kind of like bland to me.
It wasn't that. Hold on. Look. It's when you look in here, right?
But we did this.
Look how ugly that looks. I mean, that looks like the one that went on my table saw. Is what that motor looks like. There's no pretty valve covers. There's no air cleaner in there. There's no chrome.
Yeah, it looks just like a sunken hole with some jerry-rigged components in there.
Yeah, a suck hole. That's what it looks like.
A suck hole.
Yeah, 3 cylinders right there. Geo Metro. Vroom, vroom. Vroom, vroom. He actually made it sound better than a Geo Metro.
I like the way it was sounding, the engine.
Yeah. Well, because you're hearing the transmission and everything as he winds it up. You know what I mean? It doesn't have that sharp wind like everything else does.
Yeah.
Yeah. Setup. Yeah, maybe. That egg. Always at the egg. Geo Metro. All right, Ben, it's been about 2 hours. You got anything else going on?
I do not, other than just to remind everybody that I have the do-it-yourself Tesla lamp kit coming this week at some point. So we'll do a live stream. Maybe if I get it Friday, we'll do a pregame show where we go over the Tesla lamp and the kit and all that stuff. So I think that'll be fun to show everybody and to play with.
Real quick, guys. We have the memberships available on my channel. All the videos that you saw that you didn't see regularly are all on the membership side of my channel. And the next one that goes up for the emojis, we're one away from adding a new one. So you see down at the bottom right-hand corner, you see Sean on there. We're going to have the Mad Coiler be the next one for our emoji. So we just need one more member in order to get it there. And then on Wednesdays, we can start throwing up, for Sean. Now, do you guys want me to put Sean on the name or Mad Coiler? I think Mad Coiler. What do you think, Ben?
Yes, I like the Mad Coiler.
Yeah. That's what I think. That's what I'm thinking too. So, but it's pretty cool, man. Anyway, you guys get a lot of stuff on there. I know Ben and I both have a Patreon. We both have memberships available on our channels. On my Patreon, I put a whole bunch of PDF stuff on there, guys. You could download it and look at it. It's a lot of interesting over Unity, time travel, and it also has some other stuff in there as far as scalar waves. Just when you get research like that, you know what I mean? We try to dump it on there so that you guys have it all if you guys ever wanted to go on there. So I just want to give everybody that heads up before we get out of here. We'll be on Wednesday with Sean. And that should be another pretty cool episode. He's doing some great things. You see that cone coil, Ben?
Yes. And I'm really excited to see his updates on Wednesday.
Yeah, this gentleman right here dropped me a whole bunch of information, and I really do appreciate it. I want to say thank you again. It really helped me out. There's a cool John Linderman story on there that was just amazing, by the way. So
I'm putting all the I'm going to start doing this as habit and putting the whole team's link in the chat at the end of the stream, so everybody has all the links for everybody on the team. We got Nathan's channel, my channel, Sean, Ian, Michelle, Mike from Faraday Research, Mike Does, all the good channels. If you're not subscribed to any of the team members and you would like to, the links are there.
Nice. Very cool. All right, man. Yeah, right there, man. That's really cool. There's going to be a lot of good information coming out of there. We're going to do videos on Ben. So, it's been lately that I've been doing the, start off for us. So I'm going to pull some information from there and starting out the videos with that. And I'll do a presentation with it. But there's so much awesome information in there, man. And I'm trying to get that Linderman thing where text-to-speech so we can kind of watch it, and I'll put some video footage with it.
Okay. Yeah, that'll make it a little easier to set up then.
Yeah. We all work together, man. That's right. We put it together the right way.
Yes. And let's see. If I missed anybody on the team, let me know and I'll update the list. I think Mr. Lanius, I still need to put you on the list and make you a nice description as well for our link list. Because I'm putting together like a whole list of all the links for everybody's channel on the team with, convenient descriptions. So if somebody's interested in pulse motors, they know, oh, let's go to, Mike K from Faraday, or Mike Does, or if you're interested in Tesla coils, you go to your channel or Sean's channel, so they have options.
I had a question. Jarvis, are you on Wednesday? Are you coming on as well?
Oh,
him and Sean are working on those electrics, so I wanted to confirm with them.
Lanius.
You said he's busy. Okay. All right, guys. That's pretty much it. That's all I got for today, Ben.
Yep, same here.
All right, guys. We'll see you on Wednesday. I want to thank everybody in the chat for being awesome tonight. I tried to throw up as much of the chat as I possibly could. Guys, like I said, if you guys want the emojis and stuff, man, just hook up to the channel, man. It's real cheap, and you can throw them up in the chat. I love to go in there myself while we're doing stuff. But anyway, with that said, guys, have a great night, and thank you.
Thank you, guys. Have a good night.